Good morning, everyone, and welcome to today's webinar, Optimizing Sample Management with LASEC and SPT Labtech. I'm Alannah Theron, a biotechnology application specialist at LASEC, and I'll be your host for this session. It's a pleasure to have you all with us. Today's session will highlight how SPT Labtech sample management solutions can transform laboratory workflows, enabling greater efficiency and reliability across operations. In today's webinar, we will share insights on the following points: the benefits of automated sample management for modern laboratories, how SPT LabTech solutions enhance efficiency, traceability, and reproducibility, real-world examples of improved workflows in research and diagnostics, and finally, we will close with a live Q&A session to address any of your specific challenges. Before we begin, I'm delighted to introduce our speaker, Cory, the Product Manager for Sample Management at SPT LabTech. Cory is an automation enthusiast with over 11 years of experience in the life science industry. His career has spanned various laboratory settings, ranging from high-throughput blood testing to next-generation sequencing, with roles as a clinical technologist and a manufacturing engineer. His interest in the improvement led him to develop a deep appreciation for laboratory automation, and his success in managing cross-departmental projects ultimately guided him into product management. Please feel free to submit your questions in the chat or QA panel at any time. We'll cover as many as we can towards the end of the session. Without further ado, I hand over to you, Cory.
Thank you, Alannah, and thank you to LASEC for hosting this session. I just wanted to welcome everyone. As mentioned in the introduction, my name is Cory, and I'm the Product Manager for Sample Management with SPT Labtech. Today I'll be talking a little bit more about optimizing sample management with LASEC and SPT Labtech. And what I want to go over is some of the common pain points in sample management in the industry, benefits of automated tools and systems, and what kind of ways we can alleviate some of the common pain points, the SPT Labtech portfolio, and example workflows to kind of give more context to potential uses and use cases in this system. So we'll start off with the common pain points, and these will be fairly well known, received, and very common in the lab. Starting with where I like to start the most, and that is with the labware itself. So sample management labware can be extremely, large as far as the types that we allow and see. Every lab has some reasons to follow a certain labware suite or to use a certain type. So, glass versus plastic, chemical samples are more often in glass, biological or one-time use samples are more often in plastic. Septic caps versus screw caps, so there's a little bit of a generational change there. Screw caps are much more common these days as far as standardized processes, but for things like vacutainers or even compounds, there's still quite a bit of a market for septic caps. So it really does depend. Pierceable, which you can see kind of in that picture there, versus non-pierceable. And really, the big difference here is everything has a niche, everything has a space. But when I walk into labs and when I talk to lab users, one of the biggest challenges around this space is choosing a standard, picking where to standardize. And it can really be a challenge for laboratories, both big and small. At the larger size, you might have a adjacent lab really standardized on a certain size, and they are quite comfortable. But for reasons that are specific to the next lab over, there's a little bit more of a mix, and there's a resistance to standardize. And so once something has been chosen, it's also very difficult to switch in a lot of cases, because maybe you're decapper is specific to a certain screw cap, or some of your teach points in your automation is already kind of used to a certain labware type, and change can be difficult. I mean, we're human. There's change is always difficult. So it's important to kind of expand your labware portfolio and to choose your labware wisely in this field, because it has consequences downstream. Obviously, there are some real value from an automation perspective in something that's barcoded, whether 2D or 1D barcoded on the side, but standardizing to something that's trackable and traceable has some real inherent value. But this is a really common pain point for all sample management labs. Even the more advanced ones still struggle with making sure there's a standardization and a real thought behind choosing the right labware to use. One of the main points that kind of leads into that is data tracking. So data tracking, you see all types. So unstandardized processes. So we've seen a few here on the screen, and I think everyone's a little bit too familiar with how this can go. Whether it's handwritten databases or even Excel databases, which is kind of represented over here on the left. Handwritten labels, which I know was never my skill because of my handwriting. It's quite difficult to make sure you're clear, concise, and well documented on a handwritten label, particularly when samples go in and out of freezers and may see different kind of temperatures, different bits of scraping. Unorganized freezing practices is also very common. Many of you might be haunted by this sort of life of a frosty freezer and boxes, not quite knowing if this was managed correctly or if the person before put the sample back in the right place. And this really comes down to kind of tracking samples throughout their journey. More often they have to do with storage, but it could be anything in this space where you just need to find that sample, and lack of inventory procedures, which is maybe barcoding and labeling and organization, as well as lack of inventory software, which you see some examples on the right here, can really change how samples flow within a laboratory environment and how a researcher uses samples, and really kind of finding a way through this data tracking journey is extremely important to not just experimental confidence, but also automating processes and feeling comfortable and confident in the process that you have. Being able to not just believe in the physical process, but also the data journey is extremely important. These companies like Synovo, Zavo, Dotmatics, FreezerWorks, and Simplysys are just examples of some of the software out there that they all have different skill sets, they all have different spaces, but here is a potential solution to help with the inventory software part of the sample management journey. And one thing to note is that software integrations, whether with these companies or internal, they can be difficult. Making sure you have the right data structure, making sure you're capturing the right data and that it flows correctly from start point to end point is extremely important to draw out and plan out upfront with implementations, because it is more important to get the data correct, because it can have really high downstream impact. And so just to comment on these providers, we work with all of them. There's always a way to kind of look at some of the best options out there and find one that meets both your specific needs and your inventory needs. And then the last pain point, I think we're all familiar with as well. Manual tasks can be difficult in different ways, but it's just some of examples here. Hand cherry picking, so hand picking tubes, frozen sample retrieval, going in and out of freezers with your hands to pick samples are pretty labor-intensive tasks. So they can be tens or hundreds of samples and still be quite difficult whether you're in a freezer or not, because you have to find the right one, you have to search multiple boxes sometimes. And then there's other tasks that are also kind of more tedious. And really, none of these tasks are what scientists envision doing with their time. They're extremely important, but they're not quite what you signed up for, in the sense that you might have to label hundreds of tubes by hand, and after a while, it starts to look a little less polished and starts to be a little faster because you're getting close to the end. And really, I mean, this is extreme examples, but uh, being able to track data means that the samples labeled consistently and treated consistently. So, these things come into practice where they're, askew or in a wrong placement. It's very important to make sure that the impact of maybe a poor label or pulling the wrong tube or even generally mishandling a sample can have really high downstream impact and rework. Um, something as simple as a twisted label can cause issues downstream and lack of confidence. And really, you're providing a product to your end customer, and every little step adds to that confidence and that success. So some of these small things like tube labeling, vial weighing, being able to kind of automate and move through these tasks at a higher speed and a higher consistency allows scientists to do what they really want to do, which is, discover interesting results and analyze those results for better experiments. And that's really where some of the key things around sample management become not alleviating extremely hard problems, but alleviating the kind of uh, really standard task with consistency and reliability to kind of keep the lab flowing. And that's where I think sample management comes into play. Is really the backbone of laboratory process, and keep the science moving. It's maybe underrepresented in some cases and underappreciated in other cases, but it still has such a crucial role in keeping laboratories both on time and consistent. So maybe I got into this a little bit prematurely, but the benefits of sample automation or automation around sample management are quite clear to me, but I'll kind of go over a few of them and kind of where they sit in the industries. So who benefits from sample management? I think this question is valid, but reality is anyone working with samples, both in tubes and plates, benefit from a true sample management kind of ecosystem. Everything starts as a sample in a tube or well and becomes a result usually in a tube or well. So tracking that journey and being able to consistently move through that journey is very important. And this touches a number of industries. So this is a smattering of industries here. Drug discovery, which we more commonly refer to as pharma, but biotech falls into that as well. Biobanking can be across industries, but is very common in clinical and government. Forensics we're quite familiar with, but food and agriculture comes into play. Reagent manufacturing is crucial to have a solid sample management backbone. And then clinical and diagnostics is somewhat related to a few of these as well. But it's extremely important when talking about patient level sample tracking that everything's right. The outcomes can be so significant that small mistakes can be crucial to the result, or small kind of changes. So being able to track both in a quantifiable way and in a qualifiable way is very important. So applications within these spaces. Compound management is more top of mind for some of the drug discovery companies. Sample stocking, so whether it's glycerol stocking or aliquot stocking for patient samples, chemical analysis, so feeding into analyzers, sequencing, which we're all familiar with at this point, extraction workflows, sessioning, quantification, and many more applications end up touching sample management because of the actual behavior around tube management. So really versatile applications across many sectors. And that's what we're going to talk a little bit more about today, and where kind of some of the products and some of the solutions fit into these spaces. But getting more onto the benefits of sample management. So there's two buckets here, and I'll describe them more fully. But the main one that's the most top of mind for most customers and the easiest to do a business justification against is tangible benefits. So, what are the more tangible benefits of automating a process or automating a sample management process? Greater repeatability, so consistency across process. This is maybe barcoding, so for tracking, automated scanning to keep things moving, less kind of hand scanning, which you can kind of see on the top right. Sample accessioning, so if you think of an accessioning lab for pathology or for hospitals, there's this space where a new sample comes in, it's hand scanned, and the data is collected and first entered into the database, into the laboratory information management system. This becomes very crucial to get correct because that information lives on through the tests and the panels that get associated with that sample. So being able to make sure there's confidence in that space is an extremely tangible benefit to automation. And the speed and the confidence in which it can be applied. Reliability, so less rework, less downtime. So throughputs are more consistent, processes are more standardized. You can maybe take some of the human element out of these workflows so that a process might take a certain amount of time, and it's consistent across multiple users essentially. So less human bias, which can be really crucial in planning work and kind of resourcing as well. Walkaway time, I've kind of mentioned this before, but the walkaway time is very valuable for not just business utilizing its resources effectively, but also from a scientist perspective, being able to use the time to analyze the kind of more crucial data or to dive into solving that next big challenge. It's time that you might otherwise be spent, really diving into a fairly repetitive task. And that's something that automation just inherently, all aspects of automation solve quite well. Reduced labor cost has a value, of course. There's a dollar amount that we can associate with this, and that's attractive to businesses, but it's not the key focus. It's something that is always part of the conversation. Energy savings can be really crucial, very obviously able to be calculated based on the energy usage of an automated system versus a comparative manual system. This is more common for SPT Labtech with sample storage because of the way automated storage works. There's less refrigeration duty cycles, so there's less stress on the refrigeration, less power being used over the amount of samples being stored. So you actually have energy savings that are able to be tracked with the automation spend. And then space savings, typically the amount of space to do a similar amount of work on automation is less. So you might have an entire workbench set aside to do sample cherry picking, where a simple kind of piece of kit on a bench top would solve that same issue. So again, just to kind of highlight things like, even in a very highly documented process by hand, it's still very tedious to make sure you've pulled the right samples, made sure everything kind of moves in the right way, and it can be very labor intensive. So moving these processes into automation so that you free up those resources to do more interesting science is crucial. And the intangible benefits kind of come at similar theme, but are less easy to quantify. So experimental confidence, and this is something that kind of comes in along with trust, is if you don't know the precision or consistency of a measurement or a process, you are not always confident in the results. In the same way that you might not have the same level of confidence in the experiment if you're unsure of how the data is tracked or it's variable between people. Person A might have a better, clearer label than person B, which might mean that the data is not tracked quite properly in certain cases, or there's more risk to failure. So confidence in the experiment is a really key benefit of automating a process. Improve sample accessibility. Again, if things are tracked well via inventory, the sample's more clearly accessible. I know where it is. I know what it is. There's metadata associated with it, as opposed to going into the freezer and checking, or looking by eye, or guessing the volume versus actually verifying the volume. These are all things that automation brings. Improved laboratory quality of life is something that you think of ergonomics in processes. So anyone that's hand pipetted a 3D 4-well plate knows that it can be difficult to do one correctly, let alone a whole panel of plates. And so decreasing that repetitive task, decreasing that kind of difficult task can be a real clear value to automation, but is a little harder to quantify because it's more emotional than time-bound in some cases. Data integrity, again, kind of going back into experimental confidence, and then sample integrity. A lot of automated processes handle samples in a very specified way, very consistently. So you usually see a decrease in contamination, a more solid freezing or thawing profile because it's more consistent, and then the results should map more consistently based on the process. So it's a standardization of process that becomes more valuable here. And so these intangible benefits are a lot more difficult to put a value against, and they're maybe very specific to a certain customer base, but really each case, when making a justification, it's what is the benefit to my organization and what is this worth to my company? And that's where I think it's case to case, but there's always something as an example. So speaking of the benefits of automation, I kind of have an example here. And so if you're familiar with the drug discovery process, there's a few different stages, and I won't go through each one of these bubbles directly or piece by piece, but there's a lot of departments involved in even the early stages of drug discovery, so biotech or pharma. And the thing to keep in mind is all of these departments, these arrows are yellow, these yellow arrows are kind of directional in this case, but they realistically could be unidirectional in that for each department, there's this handoff back and forth with compound management. So whether this is creating assay-ready plates or working stocks or taking in new compounds from the chemistry department, from the medchem department, or testing leads again because compound management holds those stocks, it becomes this relationship that's two-way, that's crucial to the drug discovery process. And again, mistakes in one area can really compound to problems in the other. So being able to kind of show or being able to have confidence that you're creating a quality order and creating a quality product for your customers. In this case, compound management is the business, and the customers are the biology group, the chemistry group, the assay development group, the high throughput screening group, and really providing that high quality product to those customers becomes such a foundational piece of the drug discovery process that I think in some cases is underappreciated. And really treating it as the true backbone of the early drug discovery process is something that we really take a lot of stock in at SPT Labtech and really believe in heavily when it comes to the sample management part of the process. All right, so I'll talk a little bit about SPT Labtech as a whole, and then I'll get into workflows that are more specific to our products. So I'll go a little bit quickly through these slides. SPT Labtech has been around for around 25 years as a company. Formerly TTP Labtech spun off around 2000. Our headquarters are in Melbourne, United Kingdom, and we have multiple sites across the globe, commercial sites as well as production sites. And where our key applications are, and my piece is over here in sample management, mostly within sample handling and sample storage retrieval, which kind of encompasses a lot of these other buckets, whether it's genomics, drug discovery, proteomics, or structural biology. There's kind of a piece or a part to play in each. And, looking at kind of those three portfolios, there's the liquid handling portfolio, which is our largest portfolio. We have the apricot products, the mosquito, dragonfly, and firefly. And, we can always talk a little bit more about those, but I won't talk much about them today. The cryo-electron microscopy and structural biology business is another kind of wing of our portfolio. And then finally, kind of my area of sample management, all supported by our Reliance team for support and consumables, but all focus more on automated cold storage and then tube handling automation today. So just quickly to just set the scene a little bit with the kind of early stages of the company, SPT Labtech at the time, now SPT Labtech, Compound, one of the first small format automated storage units, was released in kind of the early 2000s, around 2001, and mostly focused around compound management of high throughput use of matrix 96 format tubes. At the time, they were septic caps. And coincidentally, around the same time in the US, in California, there was a company called Biomicrolab that was doing something similar around small benchtop tube handling for matrix tubes and processes around manipulation and cherry picking of those samples. And not to go through each stage here, but I'll go through the products more fully. But SPT Labtech acquired Biomicrolab around late 2021 timeline, and since we've launched the Biomicrolab Scan, we've redesigned the XL9 and 20 series, and we've launched a new storage product to complement the Compound and Arctic. There are already storage products within the SPT Labtech portfolio. So speaking of the new storage product, we have Compact. It's small, more of an entry level -20 storage system. So this is automated storage, high density, small footprint, not much larger than a typical manual freezer. The unique part of it, SPT Labtech storage, which is true for Compact, Compound, and Arctic, is the use of pneumatics to actually run the system. So each store does not store racks of tubes, they store the tubes individually, and instead of using traditional mechanical methods or grippers to manipulate the tubes within the store, we use air. We use compressed air to kind of push or pull tubes within the system. And this becomes a really robust, reliable way to move tubes and samples throughout cold storage, as well as some really unique integration features to send tubes within buildings, across labs, and really interconnect systems. So that's the kind of cold storage options. Compound being still a very robust product within this industry and one of the fastest single tube cherry pickers on the market with its unique honeycomb design. So premium features come with Compound in just size, storage density, and speed, as well as some unique features like an onboard hotel with ComStacker. Arctic is a -80 version, so a lot of the similar features with pneumatics, geared to an environment where samples are colder, of course, with -80. Samples need a certain level of care and disaster recovery, so there's redundant refrigeration and a colder input and output zone to really allow for a stable sample kind of freezing and thawing profile within the system. And then all of these come with potential accessories to scale with your workflow. So again, talking about being able to connect buildings and labs more uniquely through the power of pneumatics, there's a lot of options here. On the tube handling side, from Biomicrolab's portfolio, there's a lot of options. So there's a total of 7 products on this slide. The scan product is a smaller format 2D barcode reading sample scanner. So reading 2D data matrix barcodes on the bottom of a tube, whether they're in cryobox format or SBS format, and decoding those barcodes into an output file or a data integration as desired. So really kind of early stages of sample accessioning or verifying cherry picks or samples in and out of freezing. Volume check, VC100, VC384. It's a ultrasonic sensor-based technology to verify volumes within tubes or plates. So really crucial for adding an extra layer of metadata to a process to make sure that you're sending the right amount to your customer, or you're checking input plates to your process before wasting reagent. It's really crucial and a really easy piece of technology to utilize to verify volumes at high throughput. The XL9 and 20, they've been recently redesigned to kind of come up to modern standard. These are 96 format cherry pickers. They do have automated weighing modules as well as labeling and barcode reading. So whether they're a complement to your existing workflow, a first step towards automating, they're a real crucial kind of piece of kit for benchtop automation. And I'll get to a couple workflows that make a lot of sense for those products. And then on the XL100 and 200, we have these much larger systems that are very configurable to a given workflow. And this offers a kind of full walkaway solution around tube handling. It can be a little more complex, where you can do decapping, liquid handling, weighing, barcode reading, labeling, even on-deck cooling if you need. So it spans a lot of markets and able to kind of work within compound management or biobanking or reagent manufacturing, or even just some general sample management like labeling tasks. But the larger pick head and the larger kind of deck size allows for the ability to kind of utilize different tools and different labware into a much more agnostic space. And just to kind of show off a little bit about that, and just the kind of sheer breadth of potential modules that could go on the XL100 200 system. We have a deck and a pick head that are the kind of core features. They can be manipulated to fit different labware types or different styles. The deck can be manipulated to allow for hanging tips or even sample temperature systems, so keeping things cold. Liquid handling is an option, decapping, volume detection through automated weigh cells, so even weighing powders or weighing liquids and using the density to calculate the actual volume. Barcode reading for both side and base barcodes. The labeler can go on the front, and we even have shaking using Q Instruments BioShake if sample kind of shaking is necessary. So I'll get into a little bit more, real world applications for the XL100, because as of right now, it's all very theoretical. There's a lot of potential here, but seeing kind of where customers have used it in the past and what kind of things could be used. But starting from the beginning, when it comes to example workflows, so this will be somewhat of a build up to different styles of workflows. So something quite small, right? Early implementation of automation. I have samples in a freezer. I know they're barcoded, and I need to start getting them into a workflow that maybe doesn't need to be overly automated. It's kind of early stages of journey. But what I do want to make sure is before starting my process, I have scanned the right tubes. I know the right input samples are going into my experiment. So just as simple as adding a little barcode scanner to start with, so that you know exactly the place in which tubes are going to be used. Decap those tubes, whether using an XL100 200 style robot to decap or something similar, or even by hand. And then liquid handling. So pipetters are the most familiar, I think, for low-level automation, but the Apricot series provides some options as well for kind of early stage, easy to use, plug and play liquid handling. So something either semi-automated or small deck automated, like in this case with the S3. You can stamp out plates or move columns, dispense kind of large format liquids, one to many, or even do serial dilutions in a way that takes some of the inconsistencies of operators and hand pipetting out of it. Looking at some other kind of options here, this is more kind of pre-storage, but taking this would be a kind of a glycerol stocking workflow in my past, but taking something that's more from flask or from broth and dispensing it into maybe an analytical plate as well as some tubes. So decap the tubes, hand pipette, or use something like an S3 to dispense that glycerol stock into my destination plate, recap, scan to make sure I have everything collected from my inventory management system, and then store into a manual storage system. So again, it doesn't take a bunch of automation to start to make a process more consistent, start to make a process a little easier, and take some of the maybe where some of the human bias is most common, so data collection and hand pipetting, person to person. That's where we see a lot more of the human bias actually kind of influencing a result. We all take pride in our work, but the truth is each person seems to hand pipette a little differently. So trying to kind of remove that and add some consistency adds value over time. And so starting to kind of go higher, as you can see here, where adding some tube handling to this kind of work. So the XL20 in this case, but maybe upstream you have some liquid handling operations by hand, or we have some SPT options listed here. Decapping the tubes, aliquoting into the tubes. So basically starting with a plate, adding an aliquot to a stocking tube with an S3 in this case, recapping, and then you can scan the barcodes and label prior to storage with an XL20. So again, an extra layer of data collection. So you might think, well, why do I need a label if I have a barcode on the bottom of the tube? But in the reality of kind of how laboratories still operate today is human readable labels are still valuable to customers between labs. It keeps the data tracking not just in the cloud, but also visible. And being able to kind of create a label, scan the barcode that's associated with that label, and then archive into storage or master stocks provides an extra layer of support to the workflow. And then that XL20 can be used to pick samples afterwards, or it can be used to kind of create kind of new label designs. There's a lot of value add there. All right, continuing to ramp up here. So this is a real world example of customer workflow where they started with a plate, they run an extraction protocol, normalize that extraction to a common concentration. So in this case, we've represented a couple liquid handlers that could do that process quite well if needed. The Apricot series, the DC1 or Firefly. Normalize, we can normalize with Firefly, DC1, or Dragonfly. Decap a rack of tubes, aliquot some of that extraction, normalized extraction to that set of tubes for archival storage. And a recap, those get stored into manual freezers, and those are then pulled and rearrayed to supply customer orders. So think of a contract research organization or something similar where you're pulling tubes for customer orders, and then as they generate holes in the racks to store, they'll use the XL20 to not just pull a pick list, but also reconsolidate those racks so that they save space when putting back into storage. So again, the XL20 might not be collecting data in this case. They could read the 2D barcodes, but it's providing a consistent cherry pick workflow that ultimately influences the end customer's result. You're not digging into store for frozen tubes. You're not worried about cold hands, and really frost is nobody's friend. We're not conditioned to be pulling tubes in and out of freezers every day. and automation's quite good at it. And in the case of the XL9 and 20, they can be thrown in a cold room too if you want to kind of give that extra layer of comfort to your samples during the picking process. Moving into something that's a little bit more high throughput at one end, screening. So this would be creating assay ready plates. A lot of compounds or biologics that go into a compound screen or a pharma screening workflow are stored in tubes, so they can be easily accessed and randomized in format. So pull those sample racks from the freezer, in this case manual, thaw, scan to validate the racks that you've pulled, create a pick list based on those racks, cherry pick those into working assay ready plate stamps, decap that rack of tubes, do a tube to plate stamp to create assay ready plates, again on a liquid handler. The tubes can then go back towards the inventory. We can use volume check to check the new volume of the tubes, so minus the aliquot we've just taken out. It can be then recapped, scanned to verify, and back into storage. Meanwhile, the assay ready plates become part of the screening process, so they'll go downstream into screening with whatever screening liquid handler you use. So just to show the difference here and why automated storage provides value is the same workflow with a couple of the steps removed because of automated storage. So automated storage can provide that cherry picking function for the user without having to go to another piece of automation, as well as the scanning. So pick lists can be sent directly to an automated store. Those samples can be cherry picked into whatever format necessary to create the assay ready plate stamps. They're scanned on the way out, so they're verified that the right tubes are pulled into the right place, and then they can be processed through the same workflow. So again, it's not the only feature of automated storage, but provides less steps, more functionality, and with greater sample stability and less user touch points. So really a high value in particularly workflows that use a high amount of throughput, but even in the smaller cases where just pulling a few tubes, you get the right tube sent, it's validated, and it's been taken care of as far as temperature throughout that journey in its storage. So a couple XL100 workflows before wrapping up, but just to kind of show the XL100, in this case, without all the labels, we have the liquid handling module, the pick head, decapper, the automated balance, and then the side and base barcode reader, as well as the deck. So in this workflow, it's kind of a stocking workflow. We'll take it from, in this case, a sample tube. So a larger format, 5 mil or so sample tube. So you can scan the 1D barcode of the sample tube, which would be at this station. Decap the destination stocking tube. Aliquot from source to stock tube. So think about maybe I want to create 5 aliquots of each source tube into my stocking so that if I have plasma or patient samples, I want to make sure that I have multiple to go into my biostorage or to be ready for that next assay. So creating a one-to-many aliquot using the XL100 liquid handler, and then recapping that tube all within the same workflow. So again, instead of having multiple stages and multiple steps, the XL100 treats each tube as the unit of context, so being able to kind of move throughout those modules. And then at the end, you can scan the base of the 2D barcoded tube to verify that I moved from tube A to tube B, from end-to-end tracking, all within the same data output. It's a real clear picture of what I started with and what I ended with. There's a lot of value in the XL100, 200 as far as single unit workflow examples and a lot of flexibility to meet applications. Again, another example here, slightly different, but think about kit production or kitting for whether it's for reagent kits or for infectious disease panels, but taking a labeled reagent or a label to start with using the Label Pro, which mounts here on the front, So labeling your source tubes, you can label them one at a time, or you can label them in a batch. Decapping the tube that we want to create in our kit. Taking an aliquot from source, which could be a reservoir, could be a large bottle, could be different shapes and sizes, and then dispensing into our destination tube to make sure that we have an accurate kit ready to be prepared. Recap that tube, and then again, talking about accuracy, we have a 5-place or 4-place balance to be able to kind of verify I put the right amount of volume in that tube, and it can go forward into the next process or to the customer with a lot of confidence. And so thinking about this as an all-purpose option for early stage automation or specific process automation allows for a lot of flexibility within a workflow and a lot of power to kind of really start to automate a single process without having to worry about customer or user interaction touch points and a lot of data generated. So definitely think of it as I can import a protocol onto this machine utilizing tube management and get a lot of clear data output. So, whether starting, to summarize, whether starting in your automation journey, just starting or well-established, company big and small, there are solutions out there that can increase your workflow efficiency, increase your impact, increase your throughput, and they're, come at a variety of shapes and sizes and costs, but there's always something that can provide a lot of value without, looking too far down into huge integrated systems or something that's quite scary to implement. I suggest implementing stuff in stages so that you can kind of have a clear picture for both the today and the tomorrow. So ensure when you're considering what automation you want to build or what process you're building out, even without automation, consider both the tangible benefits and the intangible benefits, because they're both very important to justifying the solution that you bring in. And then, speaking more for SPT Labtech, you can eliminate some really consistent pain points and some really common problems with data integration with our products at SPT Labtech. Again, from something small like a scanner all the way to something like an automated storage unit like Compact. So thank you for joining us today. You can reach out to us through our link here for product inquiries, talk to any of our experts. And I want to thank LASEC particularly for hosting. Thank you.
Hey, thank you everyone for joining. I hope you found this webinar informative. I think one of the key takeaways is that as laboratories continue to scale up and handle increasing sample volumes, automation really does play a crucial role in improving efficiency, ensuring traceability, and as well maintaining your data integrity. So by embracing these technologies, we can really enhance research outputs, streamline workflows, and ultimately strengthen scientific capacity. So thank you very much and have a wonderful rest of your day.